Let us now go to the 12th sum. An electron and a proton are allowed to fall through the separation between the plates of a parallel plate capacitor of voltage 5 volt and separation distance h is equal to 1 millimeter. Calculate the time of flight. Okay, I'll come here. So what is calculate the time of flight for an electron, for a proton to fall down, time of flight for a neutron to fall down, and which falls first. Okay, so let's see this sum here. So there are two plates here. Okay, this plate is negative, this plate is positive. We have an electron and a neutron. Okay, electron has negative charge, neutron has no charge. Okay, see here this picture. Plates are reversed. Top is positive, down is negative. So proton will fall down here. Okay, and remember, electron has the least mass. Okay, proton has a little higher mass here. Okay, which will fall first? They asking. Okay, and remember, neutron is neutral. It will not be affected by the charges there. It will be affected only by gravity. Okay, so we have to find first one. They ask, okay, calculate time of flight. Okay, so which falls down first? Okay, how much time it takes? Okay, let's see this now. Very simple. How to find the time? So first you see in this case, okay, we have the formulas here. Force F is equal to mass into acceleration. Okay, we learned from Newton's second law. Then again F is equal to E into E. QE we learned. Okay, actual formula is F is equal to QE. Okay, but we can rearrange and write instead of charge we write as the electron charge E. Okay, so equating these two. So what we have is MA is equal to E into E. I'll write the step here. Equating. So equating the equations, we write 1 and this is 2. So equating 1 and 2. So what we get is MA is equal to E into E. We must find acceleration only. So bring this mass down. So A is equal to acceleration is equal to E into E by M. Okay, but what is the electric field? Okay, if you know the electric field, we can just substitute get the answer. They ask to find the time. Okay, let's see how to do step by step. So electric field. Okay. We know the formula V is equal to E into D. Okay, electric field distance. From this, what will be electric field? Bring this down. So V by D is equal to E, or we can rearrange and write electric field E is equal to V by D. Okay. So what will be the value of the voltage there? Okay. See that the question that they give us 5 volt. So voltage is 5 volt, and distance is 1 millimeter. H is 1 millimeter. Okay, 1 millimeter means 10 power minus 3 meters. So 10 power minus 3. That is 1 millimeter. 1 into this one. Take it up, it will become plus. So we have 5 into 10 power 3. Okay, volts per meter. This is the electric field. Okay, so what formula? Now we know this one, acceleration formula, and we know the electric field also. Okay, let me write that in the given side. Okay, so we have here acceleration A is equal to E into E by M. E by M, and then we also have electric field E is equal to 5 into 10 power 3 volts per meter. Okay, now I'm going to rub this out. Okay, let me rub the question also to get more space for writing. Okay, now rub that out. So we must find the time it takes to fall down. Okay, so we know 3 equation of motion. Okay, the first equation of motion was V is equal to U plus AT. Okay, second one is S is equal to UT plus half AT squared. Third one is V square is equal to U square plus 2AS. Okay, and we must find the time. Third one doesn't have time, so we can't use this equation here. The first and second one you can use to find the time. Okay, V is equal to U plus AT. Okay, but do we know the final velocity? We don't know. Initial velocity we know. Final velocity we don't know. So we can't use this. Okay, second one, yes, we can use. Okay, because yes, the distance is, they say 1 millimeter is given. Okay, H is 1 millimeter, and then initial velocity we know that is 0. It starts from 0 only. Time, we must find the time. Okay, acceleration we know, A is E by M. Okay, it's very easy to substitute and see. let me use the second equation here. S is equal to ut plus half at square. Okay, ut plus half at square. So what we get is S, the distance here. Okay, the textbook they give here 1 millimeter only, not only. So this is 1 millimeter. Okay, so 1 millimeter means 10 power minus 3 meters. Okay, is equal to u, initial velocity, that is 0. Okay, so this first term will become 0. Okay, plus half into, I need to write the 0 also. Okay, half into, write the side, yeah, half into a, acceleration we got now, this one e by m. Okay, or else let me substitute the value last. Okay, yes, since write s h itself. H was 1 millimeter. Last will substitute everything. Okay, half into a, instead of a we get e by m into t square. Okay, very easy, just cross multiply. So 2m goes up. Okay, so 2m into h is equal to e small into capital E t square. Okay, bring these two terms down. So 2mh by e into capital E is equal to t square. Okay, you can turn this side. So t square is equal to 2mh by e into capital E. So t will be equal to root of this term, root of 2mh by small e into capital E. Okay, very easy. Now just substitute. Okay, so time of flight for the electron. Okay, for the electron, that will be equal to root of 2 into mass of the electron. Okay, that we got now, it's given here, me. Okay, 9.1 into 10 power. Okay, but I don't have space here. I'll drop this out and write in the space here. Okay, so we get a much bigger space. But this is the formula. Okay, I'll write the formula on top. So time of flight is equal to, we got the formula, root of 2mh by small e into capital E. Okay, let's see this now. So very easy, let's substitute the values here. Root of 2 into mass of the electron. Now we're going to see time of flight for the electron only. Okay, mass of the electron is 9.1 into 10 power minus 31 into height, that is 1 millimeter. Okay, that's 10 power minus 3 meters, divided by E. Small e means what? It's the charge of an electron. Okay, this is not given, but we must know that will be 1.6 into 10 power minus 19 coulombs. Okay, this charge of an electron into the electric field. We now only found now 5 into 10 power 3. So 5 into 10 power 3. Okay, now we just need to solve this, simplify it. Okay, it's now clear. 9.1 this is. Okay, so first what to do is now we group all the numbers together and then you solve the powers at 10 powers. Okay, so what we get is root of 2 into 9.1, okay, divided by 1.6 into 5. In the numerator, what powers we get? 10 power. This minus 31 minus 3, so minus 34. The denominator we get 10 power minus 19 plus 3, that will come as minus 16. Okay, so take this 10 power minus 16 to numerator, it will become 10 power plus 16. That will do next step. We'll do step by step, then it will be easy for us to understand. 2 into 9.1 divided by 1.6 into 5 into 10 power minus 34 into 10 power plus 16. Okay, so what is 34 minus 34 plus 16? Okay, same subtraction only. So 2 here, 1. Okay, but before that, 1 minute, wait. You see minus sign is greater, so write minus sign first. Okay, now do it. So 2 and this 14 here. 14 minus 6 is 8. Okay, and this 2 minus 1 is 1. So we get minus 18. Okay, so in the step we get here root of 2 into 9.1 divided by 1.6 into 5 into 10 power minus 18. Okay, now it's very easy to solve this. Okay, let me write this step. Same step on top. Take some chalk also. The same step I'll write on top. Okay. It will be equal to root of 2 into 9.1 divided by 1.6 into 5 into 10 power minus 18. Okay. Now how to solve this? 10 power minus 18. Okay, root of that. We know that 10 power minus 9 into 10 power minus 9 will give us 10 power minus 18. 9 plus 9 is 18. So we can take that out. Okay, that will do next step. So answer will come to be 10 power minus 9. Okay, now root of this one, we'll solve the same. 2 ones are 2. 0.8. Okay, because 2 8s are 16. Now the decimal point is there now. So one time it will not go. So 0.8. Now multiply this. So what we get is root of 9.1 divided by, and 8 5s are 40. So 0.8 into 5, 0 here, and then 5 8s are 40 now. So 4 will go up and we can bring it down. So 4.0 will come. Okay, 4. Okay, now very simple. Do division here. 4 1s are 4, 4 2s are 8. Okay, remainder is 1. 4 2s are 8. Okay, remainder is 1, 10. Okay, 4 5s are 20. Sorry, 4 2s 8. This is 20. Sorry, this is 20. 4 5s are 20 now. It will come. Okay, now it's correct. So we get here root of 2.25 into 10 power minus 9. Okay, so for this, how to do? Root. Okay, it takes some long time to do calculation. So what we do? We'll use the logarithms. Okay, root means what? Power half. So 2.25 power half into 10 power minus 9. We'll use logarithms, that is half into log of 2.25. Okay, let me take the logbook. Logbook here. So log of 2.25. So how to do that? So half into, this is what number is there now? So write as 0. Okay, 1 digit means write as 1 less. So 22 at 5th column. So 22, first, second, third, fourth, 5th column. 3522. 3522. Okay, do the division here. 2 1s are 2, 0. 2 1s are 2, remainder is 1. 2 7s are 14, remainder is 1. 2 6 are 12, 1. Okay, so you must find the antilog of this number and into 10 power minus 9. We should forget it. Okay, so I'll write here 10 power minus 9 into antilog of what number? This one we got now, that is 0.1761. It's antilog of, okay, in the space. So now take the antilog sheet. 0.17. Yes, 0.17 is there. At the 6th column, we get, that is 1500, and first column also 0 is there. So 1500. Always when take the antilog, if there's 1 0 is there, means you multiply by 10 power 1. So 1.5 you will get. Okay. Always multiply by 10 power 1. So that's how we get 1.500 into 10 power minus 9 seconds. That means what? 1.5 into 10 power minus 9 seconds means this you can write nanoseconds. So time of flight for the electron will be equal to 1.5 nanosecond. Okay, seconds more. So this is the time of flight for the electron. Okay. Similarly, we can find the time of flight for the proton and for time of flight for the neutron. Okay, let me rub this out. So let's find the time of flight for the thing, that is proton. Time of flight for proton. Take the formula here, that is root of, we got here, 2mh by E into capital E. Okay. Now we must use the mass of proton now. Okay, be very careful. Okay. So mass of proton is here. So root of 2 into mass of proton, that is 1.6 into 10 power minus 27 into the distance h, that is the distance here, 10 power minus 3 divided by small e, that is the value of the electron charge, that is 1.6 into 10 power minus 19 into e, that is 5 into 10 power plus 3. Okay, now just see, very simple, 1.6 cancels. Okay, so you get 2 by 5. So what we get is root of 2 by 5 into top numerator we get 10 power minus 27 minus 3 is minus 30. Okay, and denominator we get into 10 power minus 19 plus 3. Okay, this is 19 actually. 19 plus 3, minus 19 plus 3 is minus 16. So minus 16. Take this numerator, it will become plus 16. So we get here root of 2 by 5 into 10 power minus 30 into 10 power plus 16. Okay, so minus 30 plus 16. Okay, again minus sign will be there, it is more. So 2 here, 1, 10, 10 minus 6 is 4, 2 minus 1 is 1, so we get here minus 14. Okay, so what you get is root of 2 by 5 into 10 power minus 14. Okay, very simple. We take chalk here. Let this out. So let's see this now. I'll write on top here first. It's easy to see it. 2 by 5 into 10 power minus 14. Okay. So 2 by 5, you can do division here directly. 5 ones are 5. 5 will not go into, write a 0 here. Decimal point. Okay. Write decimal point here. 0. 5 fours are 20. So you get here 0.4. Okay. So we have here root of 0.4 into 10 power minus 14. Okay. How to solve this? So again,